Today we're looking at compound events and looking at independent and dependent events. Please copy down the standard benchmark indicator on a clean page in your math notebook. The student will predict the probability of outcomes of compound experiments and do the experiment. Compound events, probability word problems, dependent and independent events. Dependent events are two events that are connected that the second one depends on what happens in the first one. Independent events are two events where something happens in the first one, it does not affect the second event. So today we're going to be looking at dependent events and how what you pick in the first event in a probability event affects the second one. Number 1. The names of 7 boys and 10 girls from your class are put into a hat. What is the probability that the first 2 names chosen will both be boys? So, first we have to figure out the probability of the first event. There are 7 boys out of 17 kids. So the first event has a probability of 7/17. Next, we're going to multiply it by the next event probability. So now we only have 6 boys' names left, and there are only 16 names left in the hat. The second event is a dependent event because it depends on what was chosen on the first one. If a boy is chosen for the first one, there aren't as many boys' names, and there aren't as many names in the hat anymore. So now we can simplify 6/16 to make this easier to work with, especially as we get to the end of the problem so our numbers aren't as big. So we can divide both of those by 2, so we're going to get 3/8. We're going to have 7/17 times 3/8. Okay, so now we're going to do 7 times 3 is 21, and now we need to do 17 times 8. So then we get 21 over 136. We have to check and see if we can simplify. 21 is divisible by 3 and 7. 136 is not divisible by either. So the probability of the first 2 names chosen is 21/136. Problem 2. Your drawer contains 11 red socks and 7 blue socks. It's too dark to see which are which, but you grab 2 anyway. What is the probability that both socks will be blue? Well, your first shot of pulling a blue sock is 7 blue socks out of 18 total socks. Your chance of pulling a blue sock after that, we now have 6 blue socks left out of 17 socks. Right, and on this one we can cross-simplify 7 and 17. We can't do anything with, but 6 and 18 are both divisible by 6. So we're going to divide them by 6, and we'll get 6 divided by 6 is 1. 18 divided by 6 is 3. Now we just need to multiply across. So we get 7/51 as the probability that both socks you choose will be blue. 3. An animal cage is holding 9 black cats and 4 white cats. None of them want to be in there. The cage doors open slightly and 2 cats escape. What is the probability that one of each color escapes? For this one, it doesn't matter which color we start with. So we're going to start with the 9 black cats, so 9 out of 13. And now we want one of the white cats to come out now, so we have 4 white cats out of 12 cats left in there. Okay. And the first thing we're going to do is simplify 4/12 to 1/3. Then we can cross simplify. 9 and 3 are both divisible by 3, so we're going to do that. Next, we're going to multiply across, so 3 times 1 is 3, and 13 times 1 is 13. So the probability that one of each color cat will escape is 3/13. For 4, a box contains 8 red marbles, 7 yellow marbles, and 10 orange marbles. If you pick 2 without looking, what is the probability that both will be yellow? Well, our first pick, we have 7 yellow marbles out of 25 total marbles. Our second pick, we still want a yellow marble, so now we have 6 yellow marbles to pick from out of 24 marbles. Now we can simplify 6/24 to 1/4, so we're going to have 7/25 times 1/4. And now we're going to multiply across. 7 times 1 is 7, 25 times 4 is 100. So in a dependent event, what happens in the first event affects the probability of the second event. And to figure out what the total probability of both events happening is, we multiply the probability of each event together. Please make sure you've copied all of the work down and glued this page in your math notebook.